This video, we're going to do a little bit more with transformations of sinusoidal functions and sinusoidal curve fitting. When we're talking about something that's sinusoidal, we mean things that can be written in the form of sine or cosine. And we can choose which of those functions we would want. We're not going to get into that taking data points and trying to figure out the function that goes with it. That's something that we save that for regression analysis for statistics, but it is something that's in your pre-calculus book if you're interested in looking at it. And it is a feature that's in your calculator. If you have something that appears to be periodic when you collect your data and you think you can fit it to a sine function, typically is what your calculator will use, then you can do that. So that's one of the things that's in this section of the textbook, but it's not a core objective of this class, so I have no example problems for it. Let's go ahead though and let's talk about phase shift here. So phase shift is going to happen because I have the form of a sine of omega x minus phi plus b. This is my general form, y equals of a generic sine function, or y equals a cosine of omega x minus phi plus b, where b is going to be my baseline. There, it's my vertical shift that I have. And that if I want to find my phase shift, it's related to this letter phi, which is why we use that, because that's kind of the same sound in Greek as phase, right? But we're going to have to solve for x inside here. So we're going to have to set omega x minus phi equal to 0. And then we get omega x is equal to phi, and x is equal to omega divided, or phi divided by omega, like that. And this right here is our phase shift. We've talked about this a little bit before, but my period is going to be, in these sine and cosine functions, is going to be 2 pi divided by omega. And you know that your amplitude is going to be the absolute value of A. Those are the main characteristic things, and you're going to have all of your characteristic points are going to be shifted by your phase shift. And then last thing that you do, but with order of operations, is do your vertical shift on those points B values. So let's go ahead and let's get rid of all of this and let's do some graphing. You do want your omega to be positive when you do these, so make sure that you use your even odd identities to write this as omega x minus phi before you get started. If you're asked in your test to identify what omega and phi are, make sure that you've taken that -1 outside of the sine function if necessary, if your x is written second in the subtraction. So let's just graph these. And it says to graph at least one period, 3 sine y equals 3 sine of 3 pi x plus 2. So I'm going to show you that one full period here is going to be a 0 to a minimum, to another 0 to a maximum, and back to the 0 again. So those are some estimates right there. If we wanted to figure out exactly what's going on, my phase shift is going to be -2 over 3 pi, not a very nice number, right? So that's why it's just giving me decimals there. and my period is going to be 2 pi over 3 pi is going to be 2/3, and my amplitude is going to be 3. And that's what's going on with this sine graph over here. So you need to graph at least one period of that. Let's look now at the next example. Is 3 sine of 4x minus pi. So that doesn't have the pi as a multiplier. 4x minus pi. And we can go from this 0 here to this 0 over here and be in good shape for one period. That's not that hard to get these points that are here and put them on the graph there. So let's figure out again that my phase shift, my phi over omega is pi over 4. And that my new period is 2 pi over 4 is pi over 2, and my amplitude is 3. And I can see that that's what's going on with this graph here. Again, just make sure to get one period. In this example right here, I've got my cosine function here. So I again am going to figure out my phi over omega is going to be negative pi over 2 is negative pi over 4. And then I have my period is 2 pi over 2 is pi, and my amplitude is 3. So let's graph that. You'll see that cosine of 2x plus pi over 2. And again, we only need one period. This is really more like a sine function in disguise because I can start it right there at that 0 and come this way. Look at how it was shifted pi over 2 units, and you'll say, oh yeah, that looks like something that could be a co-function identity kind of going on here. So this looks a whole lot like maybe this could be, let's see if I can figure out what it would be. Maybe this is 3 sine of, maybe this is negative 3 sine of 2x. Let's see if that's it. Oh, look at that. That's exactly what it is. Okay. So I could have written that cosine function right there that looks a little more complicated as a simpler sine function by using my co-function identities. So let's look at this one though. There it is. And now let's look at this next one. Again, this is going to look like it's a sine function, but it's really a cosine function in disguise. Same kind of thing. So let me graph the original function here, 3 sine of 2x plus pi over 2. And I'm going to graph right on top of that y equals negative 3 cosine of 2x. And you're going to see that it's the same thing because of our co-function identities and our even odd identities, that function and that function are the same thing. So I could say, if I were looking at this as the cosine graph here, which is really the simpler one to look at, that my omega, sorry, my phi over omega is 0, and my period is 2 pi divided by 2 is pi, and my amplitude is absolute value of negative 3 is 3. Same thing, I would try and simplify this one down here first, and I said that that was -3 sine of 2x when I was looking at that one. So that one is going to be just a second here. If I simplify that down first, this is -3 sine 2x. I have a phi over omega of 0, and then a t equals 2 pi over 2 is pi. And then I have an amplitude of absolute value of -3 is 3. Okay, so let's move on. We have a couple more examples here. Let's make this +3 sine of pi x plus 3. And that doesn't look exactly like a sine or a cosine graph because of its phase shift. It looks a little closer to a negative sine graph. But let's deal with it like it's a cosine graph, like it got shifted 3 over pi units to the left here. And then it has so we'll say that phi over omega is going to be -3 over pi. And that our t is going to be 2 pi over pi is going to be 2. And our absolute value of a is going to be 3. And that's what we're going to see here for this graph. And look at the x-intercepts to help you and get at least one period of this when you draw your graph according to the instructions. All right, let's keep going here. Just a few more problems. 5 cosine of -4x plus pi over 2. Remember what I told you about we don't like omega to be negative, so I'm going to change that up and say that this is 5 cosine of 4x minus pi over 2. Or I could have written that as pi over 2 minus 4x. And if I would have seen it that way, then that would have changed this into 5 sine of 4x. Let's just go ahead and write it that way, 5 look at that, that lies right on top of that. So that's a simpler function than this. So our phi over omega is 0. Our t is 2 pi over 5. And our absolute value of, over 4 is pi over 2. And our absolute value of a is 5. And that is what we see here, that we have an amplitude of 5 and that we have a period of pi over 2. Now let's look at the next example here, 4 sine of -2x minus pi. Again, we want to make that omega be positive, so this could be a -4 sine of 2x plus pi. That makes phi over omega and -pi over 2. That makes our period 2 pi over 2 is pi, and our absolute value of a is going to be 4. Let's take a look at this graph. Like so. Oh, that looks a whole lot like a compressed sine graph to me. It looks like it's just going to be sine of 2x, and if I knew some difference identities. I could show you why that is, but let me just tell you that if I make this a 4 sine of 2x, it's the same thing. So if I had used some trig identities to simplify this down first, then I would have a simpler function of 4 sine of 2x, and then I would have no phase shift, and I'd have a period of 2 pi over 2 is pi, and an absolute value of a is 4. That is what we see going on here. So again, it really helps if you can use your identities to simplify your functions down before you graph them, but also I want you to see in this section especially that I can graph the complicated function and graph the simpler function, that they lie on top of each other. All right, last one, -3 cosine of x minus pi. We can see that that is just a regular old cosine looking function here. So I just want to try and see if y equals 3 cosine of x is the same thing, and it most certainly is. So y equals 3 cosine of x. So my period did not change. My amplitude is the only thing that changed in this graph. All right, that's it for this video. I know that one was a little bit longer, but I wanted to show you some simplification and how that got rid of our phase shift lots of times, not every time. And phase shift is the thing that we like least. So if we can simplify the function to get rid of the phase shift, that's really to our benefit when we need to go and graph these things and talk about them later. All right, see you for the next chapter, because we're done with this chapter.